Good morning, everybody. Today I am going to discuss the remaining portion of the partition function that we have discussed in the last class in my previous video. Today I am going to discuss the partition function again, and what are the parameters we can derive from partition function. For example, free energy, and entropy, and pressure, volume, temperature. What are the parameters we can derive from partition function? And this is very important. All the derivation will not ask in the net gate exam. In exam, what happens? They will give the partition function. Okay, partition function of one-dimensional or two-dimensional. And after that, they will going to ask you what is the chemical potential, what is the entropy. So that means you have to know how to derive. Okay, and sometimes we have to use a lot of mathematics in between in deriving all this theory, and we have to know. And that's why I'm going to give you that basic idea how to derive and what to derive, and how to remember the mathematical equation. That's what I'm going to give you. But before going to that, some important parameter I want to highlight. Important parameter. What are the important parameters we have to remember? So yesterday we have encountered three entropy relations. Okay, entropy we are getting three relations. Okay, one entropy formula is, we already know, K, ln omega. Omega is a number of microstate. Okay, then another formula we are getting minus K K sum of PR ln PR. This is, and for degenerate system, non-degenerate system, GR equal to 1. This two formula. Okay. Okay. Sometimes what happens? This is, and partition function general formula. Partition function density of state. First with density of state. What are the general formula? Density of state proportional to E d by S minus 1. You remember, this is very important. Okay. Another normal formula, important formula, precipitated low temperature proportional to T d by S. This is general formula. You have to remember. Okay. Another formula I'm going to give you the pressure. So why I'm going to give you this pressure you have encountered. See, one important question. So pressure in thermodynamical relations we have already studied in SS also, BSc also. In classical ideal gas we always written by 2 by 3 U by V. Is it okay? Pressure in ideal gas that we have already studied in SS and BSc also. But have you remembered the pressure in black body radiation is 1 by 3 U by V? Or this is energy density, you can 2 by 3 U. U means U prime is the energy density. Okay, you can here also if you want to write. Okay, this is a pressure formula. So general pressure formula is, remember, general pressure formula S by 3. Okay, 3 is the dimension. Okay, remember, 3 is the dimension. S is the integer value. It will according to the dispersion relation. U by V. This is general relations. So when I encounter ideal gas means classical ideal gas following the Maxwell-Boltzmann statistics and Fermi-Gauss statistics in non-relativistic case. We always replace this one P square by twice m, right? So P square by twice m means P equal to H cos K. H cos K square by twice m. So dispersion relation E is proportional to K square. 2 is number. So in this case S equal to 2 for this case. Okay, then we get E equal to 2 by 3 U by V. Okay, and in case of photon or phonon, any particle that follow the dispersion relation, E is proportional to K to the power 1. Yesterday I had shown from where I get it, because E equal to PC, P equal to H cos K. So E is proportional to K to the power 1. In that case, S equal to 1. Okay, so S equal to 1 for black body radiation, S equal to 2 classical non-relativistic particle, for example ideal gas. Okay, these are the three general relations. you remember that this is very important formula in order to avoid calculation, because in exam you have to see the question, you have to find out the answer without going to the calculation. This is the tricks if you want to qualify. Okay, competitive exam, so you don't think that I will derive, I will do the calculation in the exam, I will find out the correct answer. No, you must have some basic idea. There will be 4 answers. Out of these 4 answers, 2 is totally impossible answer and 2 answer is very close. Okay, these 2 answers you have to use in your mind, how to find out the correct answer. In that case, you have to use some logic so that you can easily find out the correct answer. This is the strategy. Okay, this is the general formula, and first of all I want to, and another general formula I have not given, partition function. Sorry, partition function general formula. This is for n numbers of particles. Remember this formula, this is very easy. Vd, okay, Vd, then Hd, then twice pi mkt d by 2 to the power n. And why I am writing n? N is for n numbers of particles. For if you want to remember the partition function of single particle, these are the general formula. Okay, and then it's for single particle n factorial will not be there, and if it is for distinguishable particle, then 1 by n factorial will not be there. For indistinguishable particle, there will be 1 by n factorial. But remember, I am telling you again, this n factorial does not affect any thermodynamical parameter calculation. Okay, this is a partition function general formula. So first of all, I'm going to give you some basic idea. After that, I will go to the numerical solution. What type of numerical solution acts in the Kinetic exam? I will discuss that question and answer solution. Okay. So another important formula I have given you: S equal to K, L and omega. Omega is a number of microsteps. Okay. Omega is calculated in classical system. In classical system, suppose a composed of system n numbers of particles. Suppose n1 number of particles in state 0 state, n2 number of. Suppose I am giving there n numbers of particles and n numbers of particles. Okay, each particle has 2 energy states. Each particle has 2 energy states. One is 0 state, E equal to 0 state, and one is E state. Okay, here n1 number is there, here n2 number of there. In this case, classical case, what is the number of microstate? You have to find out n factorial, n1 factorial, n2 factorial. This way you have to calculate. And total energy E is equal to n1 E1 plus n2 E2. After that, you have to replace this one. N1 and 2 you can replace using, in terms of E you can replace it. Okay, and n1 plus n2 equal to n. So you can replace this omega n factorial, n1 factorial, and n minus n1 factorial. You can replace this one, or after that you can replace n in terms of energy also. In this case, you have to use the classical this formula number of microsteps. But in case of quantum mechanical system, suppose in terms of quantum mechanical system, suppose I am talking about electron. Suppose if I say the electron has a two possible state plus half state. Suppose electron, I am telling like this. Consider a system of n electron. Okay, n electron. So every electron, this is the n numbers of electron. Every electron 2 state, spin up state is represented by 1 0, and spin down state represented by, this is down 2 state, another E1, E2, then E1, 2 energy state. A system composed of n number of electrons. Each electron has a 2 orientation spin up and spin down state. Okay, spin up state is a energy E2, and spin down state, this is down state, is represented by G1. This is quantum mechanical wave function, don't confuse. It is sometimes represented by this, sometimes represented 0 and 0. Okay, in that case, at high temperature, number of microstate, how to calculate? Number of microstate, you always remember 2s plus 1. This is number of microstate for a single particle. Okay, if it is n particle, number of microstate will be to the power n. Okay, now system composed of n number of electrons, so it will be n. So now consider if it is mentioned in the question, if they may not mention that it is electron, they will mention a system of n particle and each particle having two states, up state and down state. Okay, and spin of the particle is suppose half. First we consider half, then it will be 2 into s half plus 1 to the power n number of microstep. Okay, so it will be 2 to the power n step. Then in that case entropy S equal to k ln omega 2 to the power n n k ln 2. This question comes in the NET exam. Okay, we remember, we focus on that. Same question I remove it. Now again this, if I change the question, if a system of n particle, each particle has a spin 3 by 2. Spin, each particle has 3 by 2. Then number of microstep you have to calculate twice s plus 1 to the power n. That means 2 into 3 by 2 plus 1 to the power n, 4 to the power n. This 4 number, this is microstep for 4 n number of particle. Okay, if it is a 1 electron, 1 particle, then it will be only 4. Okay, so then in that case, in this case, suppose I'm formally I'm writing spin half particle omega equal to twice s plus 1 to the power n equal to 2 to the power n. Okay, I remove this part. Then entropy will be n k ln 2. Okay, suppose spin 3 by 2 particle omega equal to twice s plus 1 to the power n means 3 by 2, it will be 4 to the power n, s equal to, then it will be n k ln 4. 4 means square, it will be 2, you can replace, it will be 4. So you can replace 2 n k ln 2. Okay. Similarly for s equal to 5 by 2 particle, omega equal to how much? 5, it will be 2 to cancel, it will be 6 to the power n. So omega s equal to s n k ln 6. ln 6 you can expand, n k ln 2 plus ln t. Okay, this is where you have to calculate the entropy. Okay, I hope you understand. So next, this is the basic things. So entropy, that means entropy formula you have to use according to the numerical question based on that. So that is why understanding of numerical question is very, very essential. So next time I am going to calculate free energy formula. So free energy, when you encounter free energy, what is the formula of free energy? Free energy you can A equal to minus kT ln z. This is the formula I have already derived. So in order to find out the free energy, you have to know partition function. So what you understand that partition function is a statistical function from where we can derive all thermodynamical parameters. Okay, that is why understanding of partition function in case of 3D, in case of 2D, in case of 1D is very, very essential. So what is the partition function? General partition function. Can you remember the general partition function? 1 by n factorial. Okay. V d by h d 2 by m k t d by 2 to the power n. This is for general partition function. But I am going to consider the now suppose your problem is 2-dimensional. Then you replace d equal to 2. V square means area, it will replace by area. So h to the a square, then you do according to your calculation. And rest of the thing is very easy. But here I am going to calculate a 3-dimensional case. And you can do same calculation, only changing the number. If it is 2-dimensional, d put 2, it will be v square. V square means volume in 2-dimensional, it is area. A, you replace v by a, and h, it will be calculation will remain same. Okay, 2D, 1D you can, in case of 1D it will be 1, it will be V1 means length. After that, do the calculation. This second two-dimensional question comes in the NET exam in 2017. Okay. So I'm going to do the calculation for 3 dimension. That is why I put 3. Okay. This will be 3. So free energy will be how much? Free energy will be kT minus kT. Okay. This will be minus ln n factorial. Okay. Next term will be ln v by h cube twice pi m kT 3 by 2. So power is there. So n will come. Okay. Is it okay? Then Starling approximation, you know Starling approximation is ln n factorial equal to n ln n minus n. Okay, this is Starling approximation in statistical physics. So you replace that part. So kT, I remove minus, so it will be n ln n. Okay. Minus n ln this part. Whole part I am writing only x. Okay, do not confuse. No, I am not going to write this part. This whole part is represented by x and minus that plus n. Minus plus minus minus n1. So n is common. N will come out. Nk. I am writing here nk is common, or t is also there. T is common, so it will be ln n. Okay, this is ln a minus b form. Okay, a minus b equal to ln a minus ln b. This two term. So I directly put then the v. Okay, a square twice pi m kT 3 by 2. Then it will be 1, n is come out minus 1. This is okay. Minus 1, why n is taken out, so it will be minus 1. But suppose you understand this part, then general formula, can you formulate the general formula? General formula, you can free energy nkt ln. General formula I want to n. This is the n number of particles n. This is Vd a square twice m pi kT d by 2. Okay, this is for what? General formula for d dimension. If it is d equal to 2, then it will be 1 dimension. D equal to 1, it will be 1 dimension. One thing you can do, so you do the calculation for 2 dimensions separately and match with the general formula, the derived answer with result obtained from general. Okay. This is called Pathria. Now, how can you calculate the chemical potential? So, in an exam, you no need to, you have to derive all the time. In exam, you will give the partition function for 2 dimension, 3 dimension, whatever it is. They will ask you to find out chemical potential. So, this is how you have to ask in an exam. So, you no need to remember this formula. If you can remember, it is good for you. Even if you, all the hints and all the formula, they will give in a question. Okay. So, chemical potential. What is the chemical potential formula? So suppose you forget the chemical potential formula, how can you remember? That's what I am going to do. A equal to U minus Ts plus mu n. This is mu n this is formula. Normally we write up to this in normal way. Okay, but when we encounter a canonical system, you have to write this part. Okay. But normally free energy F equal to U minus Ts we always write. But in case of this is a canonical system, I am considering the canonical system, you write this formula. So take the differentiation. Take the differentiation, then du minus dds minus s dt plus mu dn. Why I am taking one differentiation? Because mu is chemical potential, is a constant, so there will be no variation. So mu is constant, it will be come out, then dn. Dn is a number of variable. Okay? Because in canonical system, what is a canonical variable? Canonical system variable. Microcanonical EVN TV mu. TV mu. This is the system. TVN TV mu. Oh, sorry, I made a mistake. Canonical system, microcanonical EVN. Canonical TVN. Okay, and again canonical TV mu. So here is a mu is not there, so mu will constant, it will come out. Okay, so who know this formula? The dq equal to du plus pdv, thermodynamical law. dq means tds equal to du plus pdv. So if replace du, tds minus pdv minus tds minus sdt plus mu dn. This formula, tds cancel, so finally you will get pdv minus sdt plus mu dn. So how can you calculate mu in terms of P? See, when mu equal to, you can call dA by dN, okay, du by dN. When we can calculate, use this formula, when V and T is constant, then this term will be 0, then there only this equation is valid. Okay, that is why we write Vt suffix means this parameter is constant. Constant means if Vt is constant, V is 0, this term is 0, this term is 0, dA equal to mu dA and mu equal to dA by dN. Okay, this way you have to remember. So chemical potential means dA by dN. Okay, sorry, from free energy you can calculate the chemical potential. What is the free energy formula? What is the free energy formula? You have already derived. We have already derived the free energy formula. NKT, is it okay? NKT bracket ln n by v. Okay, this a square twice pi mkt to the power 3 by 2 minus 1. This formula already I found in earlier. So this is a variation with respect to, I can simplify nkt, this ln n alpha I can put minus 1. Is it okay? This whole constant, because this is a variation with respect to n, so this term I put as a alpha is a constant, which is equal to this whole part I consider constant n alpha. Okay, and after that you just take the differentiation of this part. Take the differentiation of this part will give you first term and kt ln n alpha, first term, this term. Next term will give you nkt, okay, divided log n alpha minus kt. Okay, alpha cancel, ln cancel, kt cancel. So it will be nk ln n alpha. Is it okay? This is the answer. So nk chemical potential, nk ln alpha means what? n by v, okay, and a square twice pi mkt kt 3 by 2. This is the formula. But if you want to write the general formula in case of free chemical potential, you replace d by 2. Okay, d by 2. And these two comes from dispersion relation. Always this two comes from dispersion relation. If it is dispersion, if this is for photon, then it will be E by S. Okay, this way you have to remember this general formula. You note down the general formula. Always try to remember the general formula. Then it will save you time in exam. Similarly, what is the formula we are getting in previous calculation? Pressure. No need to remember the formula. Suppose you forget the what is the expression of pressure. You just remember that this formula that I have derived. A equal to what is this? Minus S dt. Okay. Then P dV. Okay. Plus mu dN. This formula I have already derived. So pressure equal to how much? dA by dV. Okay. When temperature and N is constant. When T and N, this suffix means this parameter is constant. T constant means this term is 0. N constant means this term is 0. Then this term and this term exists. Then pressure equal to dA by dV. Is it okay? Okay. This is okay. Now I have already derived a free energy equal to how much? Nk T ln N by V is square by twice by mkt. T is there. T by 2 minus 1. This formula I have derived. So this is variation with respect to pressure equal to dA by dV. N and T constant. N and T constant means this whole term is constant. I can simplify this equation. Nkt ln alpha by V. Okay. This whole constant term I put inside the alpha. Alpha is a constant. Minus 1. Why? Because this is variation with respect to X. Then it is a simple differentiation equation you can do. If you do this calculation, pressure equal to, you will get Nkt by V. Okay. Nkt, if I am not going to do the calculation, Nkt E by V. It is for three-dimensional case. But in case of two-dimensional case, if you calculate, this is general formula. If I write, then D equal to 2. This is 2. Then if it is D equal to 2 by 2 it will be 1. Then if you calculate the pressure, then you can get Nkt by area into D. And suppose in case of 1D P, you can verify yourself. I am not going to do L. So this is pressure for 3D, pressure for 2D, pressure for 1D. This way you have to understand. Okay. Now what type of question comes there? And after that, okay, this part I think you hope understand. Now you can. I'm not going to calculate the same way. Entropy you can calculate. Okay, entropy you can calculate. Specific heat you can calculate. Internal energy you can calculate. What is the formula of internal energy? See, internal energy you can in this formula minus d by d ln. This formula that defined from mean energy. Beta means what? 1 by kT. Okay. D beta means what? Minus 1 by kT square dt. You can replace. If it is beta is not there because that equation involves only temperature. Beta is not there. You can replace kT by 1 by kT by beta also. Then it will be easy. But if you do not transform that equation, you will transform like this. So it will be kT square d by dt. Sorry, ln z. You can do direct calculation. You can do in terms of temperature also. I am not going to do the calculation because it is simple calculation. Okay, I don't want to waste my time. So next two important theory we always encounter. One is the Virial theory, one is the Equipartition theory. Equipartition theory we have already studied in BSc level, in SS level, but we have to study in more depth in here because this Equipartition theory and this Virial theory applicable to everywhere, in classical system, in quantum mechanical system, everywhere. Okay. First of all, I will tell the Equipartition theory. Equipartition. What is equipartition theory? Equipartition theorem is telling that according to this theory, the thermodynamical energy of a system is equally distributed among all the degree of freedom. Okay. Now we have to understand what is the degree of freedom. Degree of freedom is the minimum coordinate required to pacify the particle in a space. Suppose if I consider a space, this is a suppose momentum space. Then how many coordinates required? It will be x, y, z, px, py, pz. How many coordinates? 6 coordinates required. Then there will be degree of freedom will be 6. Okay. Suppose in two-dimensional rectangular space. Then how many degree of freedom will require? 2. Then degree of 2. Okay. This way you have to find out degree of freedom. And also telling that only harmonic term contribute the energy. Only harmonic term. Harmonic term is suppose Hamiltonian of a system. If I write the Hamiltonian, be carefully T. If I write the Hamiltonian of a system is a p square plus sum of p is a q square. Harmonic term. What is a harmonic term? Only square term is contributed. If I write here is some parameter, sum of a, b, q. This is not square term. This is not harmonic term. So this term will not contribute to the energy. Okay. Okay. That is important. In crystal, you have you remember this formula? You have specific heat of solid in classical, Dulong and Petit law. We often find out Tr or Tnk. You go Nk. Nk means this is a Rydberg constant. Have you got this formula, which is equal to 5.956 something calorie Kelvin inverse. So have you remembered this type of formula in classical specific heat theory? From where this got? That is a big question. See, this is in 3-dimensional space. Basically, atom in a crystal. One thing you remember, atom in a crystal, when you encounter Debye and Einstein here, always remember, a single atom is equivalent to 3 independent harmonic oscillator. Always remember, a single atom in a crystal is considered as is equivalent, not equal, is equivalent to 3 independent harmonic oscillator. That is why energy of a Hamilton of an atom in 3-dimensional system is represented by p square by twice m plus half kr square. Okay, this means it is a 3-dimensional. This means px square twice m, py square twice m plus pz square twice m plus half k x square plus y square plus z square. So how many harmonic term is here? 1, 2, 3, 4, 5, 6. Okay, and this degree of freedom will be 1, 2, 3, 4, 5, 6. 6 degree of freedom. So passivity, this is for single atom. This is for single atom. Passivity, and according to equipartition, energy is equally distributed among all the degree of freedom, and energy associated with each degree of freedom will be half kT. So how many kT? Energy how many? Half kT. Half kT. KT plus dot 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 dot. How many? 2, 3, 4, 5, 6. 6 into half kT equal to 3 kT. For single atom, remember, for n numbers of atoms, then energy, total energy how much? TnkT. Okay, TnkT means TRT. Okay, and specific heat equal to Cv equal to du by dt equal to Tr or equal to Tnk. Tn. Is it okay? This is equal to 5.956 calorie Kelvin inverse. Okay. Suppose if I say a particle in 2-dimensional particle is having momentum this one. A 2-dimensional particle having momentum px square And sometimes what happens, they will mention as a 3-dimensional particle, but they will not write, they will not expand like px, py, pz. They will express as a p by twice m. You have to understand it. This p constant px, py, pz. Okay, don't confuse. Two-dimensional system. Two-dimensional system. They mention two-dimensional system. Two-dimensional system, and this you can do half k square. Okay, and they mention in the question that is a two-dimensional. Then you have to understand P is composed of px square by twice m, py square by twice m. Okay, not third one, pz there because it is mentioned. So similarly, half kx square plus y square. How many degree of freedom in two-dimensional system? 1, 2, 3, 4. 4. Then total energy will be for n is there, n is why n is because crystal composed of n numbers of atoms into half kt into degree of freedom 4 to cancel y's and kt. This is for two-dimensional system. Okay, and Pacific is equal to 2r. Okay, Pacific is du by dt. If it is one-dimensional, how many degree of freedom? Px1, x1, not 2. So Pacific is equal to half kt into 2. So it will be kt into n. This way you have to utilize. Do not confuse. That is why you have to read the question carefully. And sometimes what happens? Sometimes one question I have seen a net big question. They mention a system of two harmonic two particles. A system. Consider a system. It composed of only two particles. And Hamiltonian is given by this one, p1 square by twice m plus p2 square by twice m plus half k r square plus half k r 1 square. So again I am read the question. Consider a system of two particles having Hamiltonian this one. What is the Pacific? Do not confuse. You don't degree of freedom 1, 2, 3, 4. It's wrong way. Because it is Hamiltonian of two-dimensional system. This Hamiltonian is one particle, this is one particle, this is two particles. Okay, this is one particle, this is two particles. So how many degree of freedom? P1 means, you remember, P1 x square, twice m, then P1 y square, twice m, plus P1 z square, twice m, plus this stuff, half k r1 x1 square plus y square plus z square. Only 3. So this is for this two term composed of this here px, py, pz is there. 3 degree of freedom composed here and 3 degree of freedom composed here. One particle, this is total degree of freedom 6 and two particles 6. Total degree of freedom how many? So 12. We remember. Then total energy equal to how much? N is also there, N is not there because it is two particles. Then the N is 2, half kt into how much? 12 degree of freedom, 12. And number of particles 2, you have to multiply. Then it will be 6, 12 kt. This is the total energy. Okay. And don't confuse. If it is like that, don't count as a P1, P2, 1, 2, 3, 4. 4 degree of freedom. Wrong answer. Okay. This is for, and one question I have daily comes in the exam, in the net exam, 5-mark question. Question is like that, and the Hamiltonian of a system is given by px square by twice plus half ax square plus abx. What is the mean energy of the system? Can you calculate? I have already told you, Pacific it is only mean energy is only contributed by harmonic term. This is harmonic term, this is harmonic term. This will not contribute. So Pacific this will equal to mean energy equal to mean energy. You can replace equal to this is half kt. This is half kt. If the system composed of n number of particles, multiply with n. Okay, if the system composed, if they never mention in the answer, and then remove the n. So it will be how much? NKT. This term is contributed equal to 0. Only harmonic term contributed. This question comes in the NET exam in 2016. Okay. This is what theory, equipartition theory. Next theory, Virial theorem. This theory is Virial theorem. What is the Virial theorem? Virial theorem I am not going to tell. Virial theorem is a relation between average energy and the mean energy. Okay. Average energy. This is the formula. Half and sum of dV dot R, or C, you can replace half dV by dr dot R. This is the formula. Average kinetic energy, potential energy. What happened in, I have given you question now, then you will clear. This question comes in the GATE exam. If the potential, this is the formula. If the potential of the system, is, if the potential of the system is V equal to A R to the power n plus 1, which of the following is the correct answer of average kinetic energy of the system? Then you remember the formula. Average energy 1 by d half dV by dr into R. If you take the differentiation, you will get n plus 1 by 2 p. Okay, this is formula. It's very easy. In GATE exam also, you did NET exam also. and another question is, if the potential of harmonic oscillator, is half k r square, then what is the ratio of kinetic energy and total energy and kinetic energy? What is the ratio? They are asking this question asked in the NET exam. First of all, you have to find out this formula, average kinetic energy equal to 1 by half dV by dr into R. So it will be half, this is what, half, this is half k r 2 into R. Okay, 2 cancel, so it will be half k r square. Okay, it will be, that means what, average kinetic energy equal to average potential energy. So total energy how much? Total average energy equal to kinetic energy plus potential energy. So both are equal. So twice T. So ratio of kinetic energy into total energy into half. Oh, sorry, 2. 2 means 2:1. This is the answer. This is easy. And another question comes in the exam, NET exam. Suppose if you can, this Virial theorem is very much essential in classical mechanics. If you Goldstein, you can check the book Goldstein. It is central force motion chapter. I think chapter it is 5, central force motion. If you go to the central force motion, the Virial theorem is there. It is very, very essential. And even in quantum mechanics also, and thermodynamics also. This theory applicable everywhere. That is why I am giving you. And this will reduce the calculation. This simplify the calculation. Because why? Once we know the average kinetic energy, potential energy equal in case of harmonic oscillator, then we are not going to calculate the energy contributed by potential energy in quantum mechanics. So, see, total energy of a, I am giving another example. Total energy of a 3-dimensional harmonic oscillator. Okay, 1-dimensional harmonic oscillator n plus half is possible. Is it okay? So we have already know this is the total energy of the system. Now we have already established that kinetic energy equal to average kinetic energy, potential energy equal to point. This is what? This is average energy equal to average potential energy. This energy is equally divided between a particular potential energy. That means we divide this part an equal part, and one part is contributed by kinetic energy, one part is potential energy. This is why it is so important. And you can check if you want to check. Then in quantum mechanics Jatili book, okay, hydrogen and three-dimensional hydrogen atom, and hydrogen atom around I think 364 piece, and section number 5.4. You check, you will find. Okay, I'm not going to give you detail because this is time consuming. That's why I'm only giving you the way how to calculate. Next we are going to question. Next question. Okay, you read the question. This question comes in the NET 2016. You read the question. Consider a gas of n particle system. In two dimension, consider system of n particle gas placed in two dimensional box of length L and area will be L square. If the total energy is E, then find the entropy and partition free energy and partition function. Entropy you can evaluate it. What is the free energy formula? I am not going to give you the detail, but I am going to give you hints. I have given this formula, partition function. They are asking you have to find the entropy as well as free energy. Okay, entropy first of all using partition function. First of all, n, this is general formula. Ed, okay, Hd, okay, 2 pi mkt square, d by 2 to the power n. This is general formula. Okay, now they have asked the question is a two-dimensional. You put the this will be in 2D case n factorial. This will be very t square. T square means area. It will be L square. Okay. This will be A square. Okay. This will be twice pi mkt to the power n. Is it clear? Okay. Now you calculate the free energy. F equal to kT ln z. It's just simple differentiation. Simple calculation ln z. And then entropy you calculate entropy. Entropy you can calculate the formula. Okay. Entropy, how can you, what is the formula of entropy? That I have given you the formula now. dA equal to, what is the dA? S dt minus p dv plus mu dn. This I have already derived. Entropy equal to how much? dA by dt p n. Okay, n is constant. So you put it here, then take the differentiation with respect to a time. Okay, it is a very easy calculation. And next question, 2017. Why I am not giving the answer, and I am not going to give you the detailed calculation one by one because it will take time. But I am giving the hints how to calculate. It is easy calculation. Then use simple calculation. That's why I am not going to give you. And this question, net in 5 marks question, that comes in a net exam. A thermodynamical system gives free energy. I have not given you. Gives free energy Tpn U minus Ts plus Pv. This is a gives free energy expression. Remember. And if the thermodynamical function is given by this, and where you represent internal energy T temperature, S entropy, P pressure, V volume. Okay, gives energy function of Tpn. Okay, clear? Then find out the expression of entropy and volume in terms of given pressure. This question comes in 2000 net exam 2017 and 5 mark question. And how can you calculate? This is simple. Just take the differentiation. D is equal to du. This is differentiation, first differentiation. Then S will come out S dt. Next T come out P dv. Next V dv. Okay. Okay. Then what is the du means? Du from the thermodynamical relation dq equal to du plus P dv. dq means TdS equal to du plus P dv. Simple. Just replace TdS minus P dv minus S dt minus TdS plus P dv plus P dp. Okay. TdS cancel, P dv cancel. So S dt, dt is there plus Vd. Okay. So S will be, entropy will be, now entropy expression dg dt when B is constant. Okay. Next, V is expression dj by dp when T is constant. Is it okay? This is very simple and 5 mark question. Okay. And next question, a thermodynamical system, each question exists, each molecule, a thermodynamical system in equilibrium, each particle can stay T state with probability half, 1 by half, 1 by 3, 1 by 6, etc. Find the entropy. I have given you example. Entropy formula S equal to case P ln PR and PR into ln PR using this formula. Then you see this question. A single particle energy of non-interacting three-dimensional system and with momentum is equal to, carefully see. This question comes in NET 2007. The single particle, you read the question carefully. A single particle energy single particle energy of a non-interacting three-dimensional system and with momentum they have written as proportional to momentum proportional to 3. Okay. The ratio of, then find the ratio of E by E to energy density. E. Okay, this question comes in the exam. A single particle energy of non-interacting three-dimensional system which has momentum proportional to k to the power 3. This is a dispersion relation. Okay, momentum E is proportional to this one, dispersion relation. Okay, and what is the ratio of momentum energy? Okay, how, from where calculate? So what is the ratio of momentum and energy? From where we get? So I have given you general formula P equal to S by 3 U. This is energy density U. Is it okay? General formula I have given U by V. So I am simply write U means U by V, energy density. So here S is what? Dispersion relation, S will be 3. So it will be U. P pressure equal to U. So a ratio of P into this energy, P by U inch energy density equal to 1. This question is also 3 mark question. Okay, and that is why I am telling you. It's very easy, don't worry and try to understand. Next question comes in the NET exam also. This question comes in a NET exam as well as this question comes in GRE exam also, GRE physics. And this question often comes in PhD entrance, most of the institute in USA. I have collected a question from that. Okay, limb series. So pacific heat of d-dimensional crystal. Pacific heat of a d-dimensional crystal is given by pacific heat of a d-dimensional crystal is given by alpha T, beta T d by S. Remember. But I have modified the question. Okay, so that you understand the importance. Pacific heat of a d-dimensional crystal is given by this one. And remember, this alpha T, pacific heat at low temperature, this expression is valid for low temperature. Okay, the first term is contributed by electron. Second term is contributed by boson particle. Okay, boson particle means normally what pacific heat we have studied, that is due to phonon. Okay, then and dispersion relation, particle dispersion relation, E is proportional to k square. Okay, the pacific heat of a solid is given by this expression, and of a particle that follow the dispersion relation, this one. Okay, then what is the entropy of this system? 5 mark question. What is the entropy? So pacific heat, this one, entropy equal to, what is the formula? Pacific heat. What is the formula? You remember this formula? dq equal to dq equal to du plus pdv, remember. Okay, so Pacific heat at volume is constant, this term is not there, so TDS equal to du. Okay, okay, ds equal to what? Du by d. Du means Pacific heat, du by dt, right? So du means cv dt. Okay, it will be cv dt by t. So you take t. So if you take the differentiation, first term will be what? ds equal to alpha plus beta t d by s minus 1. Okay. ds equal to what we are getting? du beta t d by s minus 1. This is the formula we are getting into dt. Sorry, into dt. Okay. Now you take the integration, and we have already told you dispersion relation. This momentum P is proportional to k square. So s equal to 2, you can put s equal to 2, no problem. Or after doing calculation, you can put s. So it will be s equal to what? Alpha t. Okay. Then it will be beta t to the power d by 2 dt. Okay. Alpha t plus beta into d by 2 plus 2 plus 1 and d by 2 plus 1. Then is simple. This is the calculation. Okay. So that is why I am telling you passive heat theory. So I am reciting again, passive heat low temperature phonon contribution is always given by proportional to T d by s. This is the general formula. But passive heat electronic contribution, that is first term alpha t, is a constant irrespective of dimension. One dimension is also constant, 2d also t, 3d also t, does not affect, because it is a free electron theory model calculation. Okay. And get 2009. Okay, get 2009. Hamiltonian of the system is given by twice m plus half m omega square x square by twice x. So what is the passive heat? What is a passive heat? Which of the following is correct? Passive heat calculated. Is the mean energy. In order to calculate passive heat, you have to find the mean energy. Mean energy U equal to how much? What are the degree of freedom? 1, 2. Do not count this term. Why? Because I have told you in equipartition theory, only harmonic term contributed to passive heat. This is harmonic term, square term. This is square term, first term. This is not square term. Don't calculate. So passive heat equal to half kT plus half kT equal to kT. Okay. Sorry, internal passive heat nothing, just and if the system is n particle system, then total energy for n particle n kT. Okay, passive heat equal to du by dt equal to n equal to 1 in nk unit. Okay, remember, sometime in books it is written. What is the passive heat in nk unit? Nk unit means it will be nk equal to 1 in nk unit. Nk is considered as a 1 unit. Okay. Okay. And one or two questions. If this question comes in a GATE 2014, you can check the question in the question paper also. GATE 2014, the density function for electron gas in two-dimensional system. Which of the following is correct? Density of electron beam. Okay, you remember, you understand the question very clearly. Density of state in 2D in electron. 2D electron means E, we can replace E equal to P square by twice m, right? P square means A square K square twice m. So it is a dispersion relation K equal to 2. Correct? So dispersion relation, it will be 2. Dispersion relation 2, okay? Dispersion relation 2. That means general formula is equal to what? E d by s minus 1. So dispersion relation 2, it is for electron. In this two-dimensional case, E is proportional 2 by 2 minus 1 is equal to constant. Okay? The density of state, actually density of state or G and E versus curve is what? Constant means it will be like this. This is the correct answer. Okay? This question comes at GATE exam 2014. You can say. And this is question comes in a NET exam. Okay. Another question GATE exam. Consider a system of n non-interacting particle constant to move to the surface of a sphere. To the surface of a sphere. What is the diagram? To the surface. 2 degree of freedom. You have studied in classical mechanics holonomic constant, non-holonomic constant. Why? Because constant is nothing, just to reduce number of degree of freedom. Once the particle moving on the surface. Okay. R is not there. Only theta and phi is equal. So degree of freedom will be 2. So total energy will be half nkt into 2 equal to nkt. Okay. And this question comes in a NET exam. Carefully consider a system of particle having potential energy. Is NET question. I think 2017 this question. Having potential energy A r to the power 6. A is greater than 0 and r is the intermolecular distance. So if the system particle placed in a virial equilibrium, what is the ratio of kinetic energy to the potential energy? So it is a 5-mark question. It is very easy. Potential energy, this one. So what is the kinetic energy average? This is the formula. dV by dr into r. It will be how much? Take the differentiation, half. This will be A r 5, okay, into r. This is not 5, 6. So half 6 into A r 6 equal to 3V. So 3V. The ratio of kinetic energy, potential energy, how much? Or ratio of kinetic energy to the total energy. This is to kinetic energy. Total energy will be plus V. So kinetic energy is equal to what? 3V plus V equal to 4V. So ratio of kinetic energy, total energy. So T by V, total energy, equal to how much? T by 4. Okay. This question 5-mark question. Okay, a similar question. I have many questions. I am not going to give you all the detail. Last question I am going to tell you. After that, I will finish this part. Okay. You read the question carefully. A system of n particles interact with potential V equal to Ax. A system of n particles interacted with potential V equal to Ax. Okay. So that partition function of the system. P by S beta to the power n. So, and assume that the kinetic energy of the system is 0. So what is the partition function formula? Z for partition general formula I have given you, 1 by S to the power t, right? E to the power minus beta is, I have given you d omega, right? This is a general formula. So it is one dimensional. This called as a one-dimensional particle interact with human potential in one-dimensional case on the box. Okay, rod. Then it will be 1 by h. E to the power kinetic energy is 0. So potential energy this one. So A beta x. Okay. Then this is what? This is one-dimensional case. So you have to put dpx, dx on. Okay. No need to write all this stuff because it is one-dimensional. So this is what? With respect to x only, there is no term, only variation. Then p will come out. P will come out means p by h. Okay. Integration after that integration. Okay. This integration means one integration with respect to this, one integration with respect to this, and this is constant, that's why come out. And rest of the integration a beta x into dx. Okay. And after that you can do this is a simple calculation equal to p by h e to the power minus a beta x minus a beta 0 to infinity. Okay, 0 to infinity. Okay, put this value limit and you will get the result this one. Okay, that's all. Thank you. Thank you. I hope you understand. You go to the each and every question and how I have calculated, and request you to follow the Pathria book and everything from this book only. And this all general formula is not available in a book. You always try to remember the general formula. This will remove your calculation and you can easily find out the correct answer. Okay, exact remember of this general formula is not necessary, but always think in your mind that which is the power term, which is the variable term. If you some more important portion of the general formula, if you remember, it will help to choose out the correct answer. This is why I am deriving the general formula for sake of your benefit. Okay, thank you.